Hi, welcome to part 4 of our workshop series on COVID-19 data analytics with Kubernetes. My name is Haghighi and I'm a developer advocate with IBM. If this is your first time joining us, this is a multi-part workshop series on building, deploying and managing microservices applications with Kubernetes and OpenShift. These workshops are designed around an application that combines multiple containerized microservices for parsing COVID-19 time series data for the number of positive cases and mortality rates in different countries and regions. In this lab, we'll firstly take a look at the key features of OpenShift and why OpenShift will help developers achieve agility and speed from development to production. We will also make comparisons and contrasts between Kubernetes and OpenShift to highlight the value-added features of OpenShift for developers. We'll then dive into our cluster to create, scale, and expose our application with OpenShift CLI tool. Later, we'll repeat the same process, but this time we deploy our application with a few clicks from the OpenShift Web Console using its powerful source-to-image feature. The Web Console is actually quite interesting and you're going to like it. Here's a quick revision of what we've done together so far and how that fits into our learning journey throughout this course. We containerized our application with Docker, deployed and managed with Kubernetes, and we are going to explore how OpenShift simplifies our journey for not only containerizing our microservices automatically, but also automating deployment and maintenance. As a reminder, all the steps taught in this course are generic and applicable to applications developed in any programming languages or based on platforms of your choice. But to simplify our journey and making it more use case oriented, our course is designed around the COVID-19 data analytics and that application basically simplifies some of the functionalities. At the beginning of every part, we take a quick look at our application. This is to showcase the end result of what we do together in every part. In the previous sections, I showed you the application running on Docker and Kubernetes, and here our application is up and running on managed OpenShift on IBM Cloud. Before we view the application, here's a quick summary of the architecture and components. Our application has been developed in Java and Spring Boot framework. It provides us with a number of API endpoints for retrieving COVID-19 data per region and country, and also per dates and periods. So you can select, a set of data for a period of time for a specific country or multiple countries. It comes with a number of containers microservices, including 2 data parsers for positive cases and mortality rates per country, and a user interface for displaying data as well as invoking those APIs through a number of sample functions. As you can see from the slide here, data is fetched from Johns Hopkins University's repo, which is an authentic source of COVID-19 data, and is stored in our local data repository. Here's a list of sample API endpoints, and we'll test them out shortly. So now let's take a look at our applications deployed and up and running on OpenShift on IBM Cloud. Here's the topology view of my applications, my deployed application within project My COVID project, and in here I've got my 2 applications within one group, my COVID app. So here's my UI. If I click on the URL, I basically get my UI up and running here, and also I can go back and take a look at the deployment config from here. So as you can see, I've got the services here, I've got my build, I've got my pod, and here's the route to my data parser. So this is the data parser for the number of positive cases. I'm going to go ahead and copy this link and then connect to it from my UI. Here it is. So I'm now connected to my data parser. If I want to display all data for the country, I'm going to go ahead and pick Brazil. Let's take a look at it. As you can see, Brazil is now basically at over 20 over 2 million cases, positive cases of COVID-19. That is a very high number, and obviously we can go ahead and take a look at some other countries specifically, like for all countries on a specific date. Let's go and take 15th of July to load. So that basically shows us the number of positive cases for all countries on the 15th of July. As you can see, here are the numbers, for instance, in different regions of China, and also let's pick one country in particular. Let's go for New Zealand, for instance. As you can see, New Zealand's got 1,548 positive cases, and that's basically on the 15th of July. So if I go for a country on a specific date, and I'll go pick New Zealand, and then load. So that's basically 1,548, as you can see. So it matches the number that we just looked at from the other function. And also displaying data for a country in a period, you can say from the let's say 1st of July until the 20th of July, show me all data for New Zealand. Then click, and then you can see what's actually happening for the number of positive cases. So from the 1st of July, it was basically at 1,530, and then by the 19th it's 1,554. So that means the number of new positive cases is actually quite low. So that's basically a quick look at our application running on OpenShift on IBM Cloud. You can see it's quite simple. We've got our applications deployed here, and as you will find out during this lab, you'll be able to basically accomplish this task to deploy your applications not only from the web console, which is here, using your source code, using the Git, using the repository. You've got different ways to do that, but also you will find out how to do the same thing from the CLI. So first we're going to take a look at the CLI, and then we get to the console later. That was our application running on OpenShift on IBM Cloud. Both applications are open source and can be accessed with full instructions on my GitHub. In fact, we are going to use them for source to image demo later in this lab. Let's get started. What is OpenShift? Well, let's describe it this way. OpenShift is built on top of Kubernetes and brings along all the brilliant features of Kubernetes, but it bundles it with the essential features that will ultimately provide the best experience to both developers and operation engineers. But how does it achieve that? As you can see here, it basically achieves that through a number of automated workflows which are not available in Kubernetes. Those automated workflows are the results of these components that are drawn in this diagram. Kubernetes is wrapped around an enterprise Linux operating system, networking, monitoring, registry, and more importantly, authentication and authorization. And that basically brings us to three key important features of OpenShift over Kubernetes: automation, agility, and security. Automation is achieved from this automated installation lifecycle management on any cloud. Agility is basically achieved by the fact that it helps teams build with speed and agility and code in production level, production mode, anywhere. And also because of all those components, all those security features, you get security at every level. So I mentioned automated workflows. Let's explore them one by one. You, as a developer, want to get started on coding as quickly as possible rather than spending time learning about different platforms, tools and services, and how to refactor your application based on them. OpenShift comes with pre-created quick start application templates to build your application based on your favorite languages, frameworks, and databases with one click. So no matter what programming language or database you're using, there is a template for that. You can even define your own custom template. Second, You as a developer want to focus on coding and not worrying about what's going to happen in the background. Or let's say you want to commit and push. Deploying to OpenShift is as easy as clicking a button and enabling continuous deployment. Whether you push your updates from your Git or manually update your images and containers, OpenShift allows you to fully control the deployment lifecycle by enabling continuous integration. Third, you as a developer want to build and test your application locally without worrying about the OpenShift cluster your application will end up running in. As you will see in part 6, you can build and test your application locally using code-ready containers on your own machine. That alone eases and expedites your application development process massively. So here's an overview of what we've just explored with respect to that one-click notion of OpenShift taking care of building and deploying your application. Developers can focus on coding, and the rest of the process is taken care of by OpenShift S2I or source to image. So building your image, deploying, and as you will see later in part 7, continuous integration. So you may say, where's the fun if I still have to learn all the CLI commands and initiate those automated processes from the terminal? Well, one of the most distinctive features of OpenShift is its amazing web console that allows you to implement almost all tasks from a simple graphical interface. As you saw in the previous lab, Kubernetes dashboard is only good for displaying the statuses of your resources, and you can't deploy, control, or manage your applications, networking, or any of those from Kubernetes dashboard. Obviously, managed Kubernetes on different cloud platforms come with different sets of functionalities as add-ons, but with OpenShift Container Platform, the offered functionality through the OpenShift Web Console are vast. You can build, deploy, expose, update, and almost implement any task in two separate perspectives of developer and an administrator. We'll go through that later in this lab. You can build, deploy, expose, update, and almost implement any task in two separate perspectives of developer and administrator. We'll go through that later in this lab. Next, Kubernetes is an open source project, whereas OpenShift is a product based on an open source project, which is Kubernetes Origin Distribution, or OKD. Comparing Kubernetes with OpenShift is like that classical example of comparing an engine with a car. You can't do much with an engine, and you need to assemble it with other components in order to get from A to B and become productive. What you get with OpenShift includes enterprise support, ecosystem certification, and most importantly, regular updates and releases, security updates and releases at every level of the container stack and throughout the application lifecycle. That is an opinionated integration of features to simplify and secure your application. And finally, Kubernetes offerings differ from one platform to another. Almost every major cloud provider offers a different flavor of Kubernetes. You get different sets of add-ons, plugins, and set of instructions for connecting your application to your cloud resources, which in most cases are only applicable to that particular platform. So they are basically platform specific. With OpenShift Container, with OpenShift Container Platform, your experience and the way you interact with the platform, let's say the OpenShift Web Console, stays the same. Therefore, building, deploying, and managing applications with OpenShift Container Platform is truly build it once, deployed anywhere. So in this lab, we are going to use managed OpenShift on IBM Cloud. Before continuing, let's get started by looking at OpenShift cluster on IBM Cloud and see how that basically gets provisioned. To give you an idea about OpenShift on IBM Cloud, Red Hat OpenShift on IBM Cloud provides fully managed OpenShift cluster running on a highly scalable and reliable IBM Cloud platform. This managed environment allows you to focus on developing and managing your applications while IBM basically handles the infrastructure. Additionally, IBM is delivering the resiliency to handle unexpected surges and protect against attacks that lead to financial and productivity losses. You may be interested to know that OpenShift on IBM Cloud is directly integrated into the same Kubernetes service that maintains 25 billion on-demand forecasts daily at the weather company. Once you sign up on IBM Cloud and sign into your account by visiting cloud.ibm.com, you need to navigate through IBM Cloud dashboard and choose OpenShift from the left-hand side. So if I go here, look at my clusters, here I can basically see my OpenShift cluster. I've already got one up and running. If you want to create a new one, you can basically just press on create, choose your region and zone, and then your OpenShift cluster will be ready in 10 to 15 minutes. Since I've already got my OpenShift cluster, I'm just going to go ahead and show you what is that like to look at our OpenShift dashboard on IBM Cloud. So here's our dashboard that shows our worker nodes are 100% normal and up and running, and by going into OpenShift Web Console, I can basically take a look at my OpenShift Web Console that I've just talked about. Here I basically I'm navigating my OpenShift Web Console in the developer perspective, as you can see here, and here are the applications that we just saw earlier. So I've got the death cases, I've got the positive cases, and I've got my user interface here. If I go into my administrator perspective, I can take a look at my projects. I can take a look at my workloads, including my pods. As you can see, I've got 3 pods running and residing the topology view as well. I can look at my deployments. I've got 3 deployments, so there's 1 pod for every deployment, so I haven't got any replicas. And also, if you want to, for instance, take a look at the replica sets, as you can see, there's only 1 per deployment. You get lots of features here in this dashboard. Basically, it displays the details about your build, about your services, about your routes, and we are basically going to take a look at it in the second half of our workshop later in this lab. Since we've gone through the entire deployment process using Kubernetes CLI tool in the previous lab, here we are going to take a look at how we can access our cluster using OpenShift command line interface, or CLI. Later, we'll go through the console to implement our task from a browser with 1 or few clicks. Now let's get started with the OC CLI tool. Before we can start with the OC command line, we need to install a few things. So the first one is IBM CLI Tools, and then the OC CLI based on your local operating system and the OpenShift version, and also kube control. So basically, by installing this, the first one with the IBM CLI Tools, you are configuring your terminal to access IBM Cloud resources from your terminal, and also the OC CLI is basically going to allow you to interact with your OpenShift cluster from your terminal. And because OC and kube control are very similar, with OC you get a few more commands and flexibilities and features, but then kube control is also there, since we already covered kube control in Kubernetes section in the previous section. You can go ahead and replace OC with kube control, and in a majority of cases that's going to basically work for you just fine. And then once you install and download and install this, you need to set your environmental parameters. So when you use OC and kube control, your system already is configured to basically connect to your IBM Cloud through the IBM CLI Tools. Once you've done that, you need to go ahead and log into your IBM Cloud. If you're on a federated account, you need to add --SSO, and also once you install all those components that we discussed in the previous slide, you basically get a number of plugins installed in your CLI. I'm going to basically just go ahead and show you what it's like, to have those plugins. So IBM Cloud plugin list. So here is IBM Cloud plugin list, and that basically shows you the number of plugins you've got installed on your machine. The important ones for us is the container registry and Kubernetes services, and that basically those two are the most important ones for this lab. The next item, if you want to look at your OpenShift clusters, IBM Cloud OC Cluster LS, IBM Cloud OC Cluster LS, that basically shows you the number of OpenShift and Kubernetes cluster you've got on your IBM Cloud account. So as you can see here, I've got two clusters, and one is basically in London zone, the other one is Dallas. They all have two worker nodes attached to them. This way basically you get a good idea about your clusters in case you want to check out the name and the ID number for that. In the version section, you can actually see one is 1.15 and the other one is 4.3. Obviously 1.15 is for Kubernetes. Those who are familiar with that, that's a Kubernetes version. The other one is 4.3, which is the OpenShift one, and obviously it's got OpenShift in there in the version name as well. Let's go back here. To log into your OpenShift cluster, the easiest way after you sign up on IBM Cloud, the easiest way to do that is going back to your IBM dashboard. So from here, if you go into your OpenShift section, when you are in the overview, your clusters, here's my cluster, and then you get your OpenShift dashboard here. So this is your OpenShift dashboard, and you can basically see a couple of details about your worker nodes and the sort of CPU and memory you've got at the moment, the usage of your resources. But at the same time, you can go ahead and open your OpenShift Web Console. When you click on Web Console, you get the Web Console that we're going to go through that in the next section. So in here, the good thing is under your username, you can go ahead and click on copy login command. So from here, you basically get a token, and with that token, you can just copy paste it in your terminal, and it basically got everything. You don't need to, once you've got those CLI tools, everything basically installed. All you need to do is copy paste this command and then log into your OpenShift cluster from your terminal, and everything is going to be ready. It's very quick, quite simple. I'm already logged in. I'm not going to use that, and obviously this is going to show my token as well. So I'm not going to do that. I'm already logged into my OpenShift cluster account from here. And then for you to know that you've got your OpenShift cluster, your OC initiated, so the OC is basically referring to your IBM Cloud OpenShift cluster, you need to just do the IBM Cloud OC init, and that basically initializes your OC command to work with IBM Cloud. I've already done that as well. And then the next bit that we are going to use in the first part of this workshop extensively is the IBM Cloud Container Registry. And for that one, you need to log in. So Container Registry basically comes with your OpenShift cluster, and we're going to basically look at it shortly, and the reason why you basically need to use a container registry, a private registry for your containers. Anyhow, you need to basically say IBM Cloud CR login, just in case. I'm going to basically check it out. Just log into my container registry. So I'm basically logged into my container registry, and if I want to take a look at the images I've got there, IBM Cloud CR image list basically shows me the number of images I've got in my container registry, and these are the ones that I already registered, already stored in my container registry. And then just to test out your OC and container registry, just very briefly, just put IBM Cloud OC, you basically get a few things like this. If it's an error, then that means it's not properly set up. And then IBM Cloud CR Container Registry, and that basically, these are the commands you get. So that means your Container Registry and OpenShift Cluster OC command line is actually, they're both set up properly. So let's go back in here and start with our container registries, as I had just told you about. So a registry is a service for storing and retrieving container images. Basically, a registry contains a collection of one or more Docker image repositories, and each image repository contains one or more tagged images. So there is a collection of one or more Docker image repositories, and each repository basically contains one or more tagged images. So one of the things that we're going to do here is we're going to basically tag Docker images here. And then basically Docker provides its own registry, as you know, the Docker Hub, and we already looked at it in section 2, and we also looked at IBM Cloud Container Registry back there as well. In case you want to look at those information, you can go back into the Docker section in part 2 and look at, you know, some information about building container images and also running containers. You can go ahead and take a look at that lab. But obviously you can always use your private or third-party registers other than Docker Hub, and this is basically the purpose of this IBM Cloud Container Registry. And as I've said to you, by default, your Red Hat, OpenShift, and IBM Cloud clusters are set up with an internal registry, which is this IBM Cloud Container Registry, and that is for storing images locally in your cluster. And the clusters are also set up with image pool secrets, and that is something that we're going to take a look at it shortly. But those image pool secrets are set up in your default project to pull images. So I'm not going to go into details at the moment. What we're going to do now is we're going to basically go ahead and create a new namespace in our container registry. The way you do that is IBM Cloud CR namespace add. So I'm going to do that. Let's clear here. IBM Cloud CR, and then you need to add namespace add. Then I'm going to call it testing, just to call it testing, just to see what it is, or test repo. Let's call it test repo. So this is the namespace. So the requested namespace is already in use in registry. Okay, so that repository already exists in my container registry. So what I'm going to call it now is going to call it my app repo. Maybe that one is a better one. So yeah, my app repo, I called it my app repo, and that is now unique to my IBM Cloud Container Registry. One thing you need to remember is the way it works is basically your as you can see, I'm in zone US, so it's usicr.io, and then a slash namespace, and then a slash your image name. So if someone else has already got this namespace, that's not going to be allocated to me, because that basically is going to be used in the URL for this namespace. So that's why it's really hard to find sometimes, like, you know, for common words like, you know, test repo, because someone else might have had it already. So we've got it now. So the new repository, the namespace in our container registry is called my app repo. Let's go back here, and then I'm going to basically tag one of my applications, the ones that we looked at in the previous lab and the one before that. I'm going to tag it with usicr.io namespace and then the image name. So let's take a look at our Docker images here. So I've got my app UI death and my app, which is the positive number of positive cases for COVID-19. So what I'm going to do is I'm going to use the bottom one. Let's say Docker tag, and then I'm going to choose my app v1, and then what I'm going to do, I'm going to usicr.io, and then our namespace, which was my app repo, and then my app v1. So that's basically, I'm tagging my Docker image. So it's already tagged. So one thing you need to remember here, if I go back to the previous slide in this one, that IBM Cloud CR login, what it basically does is it logs your local Docker daemon in your machine into the IBM Cloud Container Registry, and that basically allows you to interact with it. So remember that one. The reason we are using Docker is because it's already using that Docker daemon into IBM Cloud Container Registry. So in case of any confusion, like the way we basically use the Docker daemon inside Minikube or Kubernetes cluster basically to tag and push our images. So I've already tagged my image, and the next part is I'm going to basically push it. So what I'm going to do is now Docker push, and then the same one. So I'm basically going to push it now up into my container registry. So as you can see, this is now happening. It takes a little bit of time depending on the size of your image. And once it's done, we can basically go ahead and take a look at it, whether it's already in your container registry or not. The image is kind of large. It's about 300 megabytes, so it needs to push it. So that's why it's taking a little bit of time. Obviously, it's a Spring Boot app, and obviously it's got a lot of dependencies and libraries, and that's one of the reasons why this image is quite large. Now my image is successfully pushed into IBM Cloud Container Registry, and I can basically take a look at it. IBM Cloud CR image list, and as you can see, I basically got my app here. So this is my new image that I've just pushed. So as you can see, the namespace is my app repo. The other ones that I had was COVID test, and that was basically just to test it out to make sure that everything works perfectly before I present this to you. So my app repo has been perfectly pushed into IBM Cloud Container Registry. Let's go back here. Now from here we are going to start using the OC command, and the OC command, as I said to you, is very similar to the kube control that we used in the previous lab for Kubernetes. And all you need to do is OC and then the type of action, what action you want to perform. Is it like get, describe, create, things like that that we used before. And then the object type, is that a deployment, is that a service, and then your object name, if again the name of your deployment, the name of your service. That's the way we are basically going to use OC. And OC is kind of considered your magic word for telling your terminal to interact with your container, with your OpenShift cluster. So a few tips or a few useful commands. OC projects basically shows you all the projects or namespaces, in Kubernetes context. And then OC project, your project name, basically you can switch to a new project. Let me show you now. So from here, I say OC projects. It basically shows all the projects in my OpenShift cluster, as you can see here. And now I would say OC project default. It is going to switch to my default project, as you can see here. And then the other one is OC new project, and with new project you can create a new project in your OpenShift cluster. I'm going to create a new project, OC new project. Let's call it something like the one that we called our container. Namespace, my app repo project. It's kind of a long one, so my app project, I would call it my app project, might be better. So now we've got a new project, and it's going to create it and also using it. So if I say OC projects now, it's going to show me all the project names. and also putting an asterisk next to the project I'm using, which is my app project, and also it says here using project my app project. I'm going to go back into my default for some reasons that you're going to find out soon. See project default. So now we're going to be back into our default project. The other thing is, if you need help, with some commands, you can get a list of full commands basically from OC, like OC --help. It shows you list of all commands from advanced to basic ones, and also for pushing and pulling and building and deploying commands. This is quite useful. And also there is another command which is called explain, OC explain. And if I put like OC explain project, for instance, if you want to get more information about it, you don't need to go back and forth between the documentation online. You can just get the data, get the information here on in your terminal. So for instance, projects are the unit of isolation and collaboration in OpenShift, blah blah blah. So you basically get some idea about this type of resource or terminology. So this is quite useful to make sure you use explain and help when you need. The other one is edit. Edit is quite useful. OC edit, you can basically edit some of the existing object types and object names, by just using them. So like edit deployment, and then your name of deployment, or services and name of services, and then you can basically go into the YAML file and things like that. And the other one is patch. It basically does the same thing, but you can basically take care of more fields of an object, one or more fields. And with the OC patch that we're going to use shortly, you get a lot of options basically, and also those options can be changed in JSON or YAML expressions containing the new field and values. This is very useful, and we're going to use this later. So remember these commands just for now, but the one that is important to us is the OC new project, and also OC projects that you can switch back and forth between different projects and also create a new project. Let's go to the next one. So now we've already got our app in our repository, and what we're going to do now, we're going to basically start pulling that app from our OpenShift cluster, and then create a deployment. So let's go ahead. From here we say OC create deployment, and then I'm going to use let's see, IBM Cloud CR image list. Just let's take a look at the image list we've got. So this is the one that we are using, my app. So I'm going to basically deploy this one. Create deployment, and then the image is going to be this. And make sure you use the tag as well, which is v1. All that basically. Create deployment image. See, create deployment image for help. So we did something wrong here. Oh yeah, I had to include a name for my deployment, which I totally forgotten. So let's call this my app deploy. So as you remember, we basically use my app repo and then my app project, and I'm going to call this my app deploy, just in case, just to remember, the sort of resources we're using. So my app deploy, and that's it. My deployment is created. So the next bit is just, let's take a look at it. OC get deployment. Just make sure that it's been pulled successfully and the deployment is available. It is available. It's 1 out of 1. It's ready. It's available. Age is 11 seconds, so that means it's the same one. And then let's take a look at our pods. OC get pods, just to make sure our pods are also there. We've already gone through this in our Kubernetes section, so just make sure you check that out in case you are not familiar with pods and deployment. Everything we are talking about here, we've already covered that in the Kubernetes section in the previous lab. So as you can see, our pod is also healthy and up and running. So just let's take a look at OC get events. Again, if you remember, it was kube control get events, and you can see that it was trying to pull, it pulled it, then created, it started successful create, and then blah blah. The other ones are basically from 38 minutes ago, so don't look at the ones that it says killing and deleting and all that is stopping. The ones on the top are the ones that you are basically we used it here, as you can see, it's 51 seconds ago, 46 seconds ago, etc. So our pod is also healthy, and now we are going to expose it. OC expose, again, exactly like kube control that we used in the previous section. expose deployment. Let me just get the deployment. OC get deployment, just to make sure we're using the right name. So that's the name of our deployment. OC expose deployment, and this is the name of our deployment. And then we need to, as you remember from the previous section, our positive, the parser app that gives us the positive data, positive cases for COVID-19, it is running on 8082. So you need to specifically mention what port is going to use, and then the type of services is load balancer here. So I'm going to say port and then 8082. And this is the container port for the pod, so it is within inside the pod that the container is going to listen to it, and that basically gives us a port, a node port, basically to kind of get the traffic, to get the traffic inside the cluster. And then the type is type load balancer. Again, if you're not familiar with what we are talking about here about the type of port, you need to check out the previous section. We went through this extensively and we talked about it. So port number, and then the type is a load balancer. Just let's check it. Expose port 82, all good. Hopefully we'll go ahead and expose it. Okay, our app is exposed. Now let's see X get services, just to make sure there's everything correct. Oh, we've got a few ones. These are the ones from before, but the one that we called it my app deploy is this one. Again, as you can see, I've got some of the ones which are quite similar in name into this one, but obviously the ones that I was trying to test out before recording this. So my app deploy is the one. The external IP address is 169. We can basically just check it out here. Let's say curl and then the IP address, and then I'm going to use the port. This is our port for external traffic, and then if you remember, it was hello, so it should tell us hello world. 2020 should be fine. Yes, hello world. So our application is working perfectly, and it's been exposed and it's up and running. If you want to get some idea about the application, for instance, if I say get country data and then Germany, if you remember, it should give us all the positive cases of the number of positive cases in Germany. So take a look at it. Yes. So on the 26th of July, there are over 206,667 cases basically in Germany, as you can see here, and that's basically all the data. If you want to check it out from our browser, we can just like copy paste this. Let's get it here. So as you can see, here's the data from a browser. All the data, and if I go all the way down, for the 26th of July, we've got 206,667 cases, and that's basically our app. So this is for the positive cases. I can do the same thing with the UI. I'm not going to do that now. We're going to basically leave that for the console section. This is just for the CLI, and just go through that very quickly to see what it's like to deploy and expose an app. So let's clear our screen. So as you saw, we basically deployed and exposed our app perfectly. It managed to, because we were in a default registry, it managed to pull the image from IBM Cloud Container Registry perfectly without any problem. But one thing you should know is, by default, your Red Hat OpenShift on IBM Cloud clusters are set up with an internal registry, as I mentioned earlier, that stores images locally in your cluster. And those clusters are also set up to pull, basically set up with image pool secrets in the default project, and we were in a default project. That's why it worked perfectly to pull images that you stored in your private IBM Cloud Container Registry repositories. So in that repo, we had an image, and we managed to pull it perfectly without any problem. Because we were in a default namespace or default project. When you create a new project, you need to set up a few things that we're going to basically mention shortly. But when you set up the OpenShift internal registry to import images from IBM Cloud Container Registry, you get the advantage of a private registry that is common to multiple clusters. So these are the advantages. And another benefit is that the copies of the pulled images from IBM Cloud container registry are stored locally on the cluster, and therefore it basically reduces the latency and the external traffic, and that's a very, those are really good advantages. But obviously you're subject to some storage limitation, and obviously you need to do a few more things just to set it up. So if you are going to use the default namespace or default project, you don't need to set anything up, you can just go ahead. But if you want to use a new project and create a new project, as we did earlier, but we quickly switch back to default, you need to create image pull secret. And image pull secrets basically are good to pull images from IBM Cloud Container Registry to your OpenShift cluster. You can push it also, create image push secrets to push images from your OpenShift cluster, and also you can use it for both cases. And the advantage of that is, for example, if you want to set up a continuous delivery pipeline, like CI/CD, that builds an image to a private registry instead of the internal registry. Those are really good advantages that you get. And also, one thing you should know is every OpenShift project has a Kubernetes service account that is named default. So the one that I mentioned earlier about the default project, this is different from a service account that is called default. And this default, the service account, basically within the project you can add the image pull secrets to this service account to grant access to pods to pull images from your registry. So you need to first of all create an IBM Cloud IAM service ID for your cluster. So that's the first one. The second bit is you need to create a custom IBM Cloud IAM policy. So as you can see, like the IAM, so first you create your IAM service ID, then create an IAM policy for your cluster service ID for the previous one, and then you create an API key for the service ID. And with that, you can create an image pull secret to store the API key credentials. So in some ways, you're basically giving access, you're giving your username and password to your project or to your pods, basically to pull images from your container registry without you actually doing that, and without you passing your actual username and password. So by creating an API key using your service policies and service ID, you're granting that access to your project. This is very important and very crucial when it comes to enterprise applications and type of applications that needs a lot of security around it, and you want to have full control over your different projects. If you have a development project and a operations project, this is actually quite useful as well. And then the last bit is you need to store the registry credentials in a Kubernetes image pull secret and reference this secret from your configuration file. Obviously for part 4, for the step 4 and 5, we are going to do it together in one command. And the last bit, as I said, about the default service account, that would basically get the sufficient permission to go ahead and pull images. You need to add this image pull secret to your default service account. So first you add it to your Kubernetes, and then you add it to your default service account. This is like, so we are going to go through these 6 steps very quickly, but once you learn this is a very useful thing for you to know, and it helps you a lot to understand the interaction between pods and projects and your container registry. Later we go through the same setup in our console, from the console, and you can see that it's as easy as a few steps on the console that you can go through the access and add this through the role binding from your project. It is very quick, again, from your console, web console. But here we are going to show you how to do this from the CLI. The first step I'm going to basically try is I'm going to show you that for this project that I said OC get secrets, and then default, that's the default project that I'm in at the moment. I'm going to show you all the secrets basically in there. You can see we've got a number of things, and all ICR.io, as you can see, that's basically the one that gives access to the IBM Cloud Container Registry, and that basically is the secret to why the default namespace is capable of doing that, because that secret is attached to the default service account within the default project. And we are going to now let's take a look at our projects, the one that we created earlier. So we created my app project, if I remember, my app project, that's the one we created, and we are going to basically grant enough permission to this my app project, to its service account, to its default service account to be able to pull images from container registry. And the first step is I'm going to basically first of all switch to that, my app project. So now I'm using basically that project, and what we're going to do here is you're going to use the IBM Cloud IAM service. The first step, as I mentioned to you, that we need to create a service ID. So I've got the commands here. I'm going to just copy paste it to make it easier and save some time. Let's use the one below. So in here, I'm going to basically show you everything you need to basically put into this command. So IBM Cloud IAM service ID create, that's the part that you're basically telling IBM Cloud to create a service ID, IAM service ID. And then for this part, this is the name for your service ID. What I'm going to do is I'm going to use my cluster name. Let's get our cluster ls was OC cluster ls. So that basically gives us the cluster names. So I'm going to use my cluster name, and then the project name, which is my app project, and then ID. So it kind of gives me the idea that it's in this cluster and this project, and then ID, just to say this is the ID, service ID. And then you can just put some description here. This is good just in case you want to check it out later. Service ID for cluster my OC 83243, and project my app project ID. That's all. So now we are creating a service ID. So the service ID is created. The next step is to create a custom IBM Cloud IAM policy for that cluster service ID. So now we are going to, the next step is, let's take this up. Next step is this one. So let's create so the first part is IBM Cloud IAM service policy create. So last part was service ID create. This is a service policy create, and then IAM service ID, the one that we've just created. So the one that we just created is called my OC. This is the ID. So make sure you just copy paste it, just it's easier. And then the roles basically it's not manager anymore, it's called administrator. So basically you've got a viewer, editor, administrator, now you've got writer, reader, and then administrator. It basically throws you an error in case you make a mistake, so you know exactly. But I'm going to give it administrator role, so for it to be able to access everything. And then the service name is going to stay the same, container registry, because that's basically the service name for this service policy. So that's it. Let's create that. Failed, was not found, valid. Okay, so now it's back again. I need to use a capital. As I said to you, you can see you've got viewer, administrator, operator, editor. So it's up to you which one you want to use. So I made a mistake, so I need to use capital A. That's it. My policy created, so creating policy under current account, and that is it. So I basically got that. And now if you go back here, the next bit is now to create an API key for the service ID. So we've got the service ID, service policy, and now we're going to create the API key. For this is this command. Let's use it here actually. I'm going to okay, that's fine. API key, let's call this, so the service policy ID that we just created, it was service ID. Let's put it here, and now the API key name. So just choose a random name for your API key. I'm going to call it my app project API, and that's it. So this one again, look at the command IBM Cloud IAM Service API key create. Again, quite obvious, you know exactly what you're doing. And then your API key name, and then your service ID, and that's it. So once you put all the information, enter, so we should actually create my API key. So now I've got my API key, as you can see here. This is very important. Make sure you don't share it with anyone, you keep it to yourself, because that API key can give administrator access to a lot of things within your project and your cluster. So make sure you remember that one. And now what we're going to do is, in the next bit, we are going to create an image pull secret to store the API key, the one that we created, and store the registry credential in Kubernetes. If you remember from this slide, as I said, we're going to create an image pull secret and then store the registry in a Kubernetes image pool. So we are going to basically do this in one simple step, and the way we do that is this command, as I will show you shortly. Let's copy paste it again. I'm going to clear here. So let's do this. So for the email, you basically just need to put some random email if you want, but you need to use a good email, but it's not going to be used for anything. It's just something that is needed. The API key, I'm going to use this API key that we just created, and that would be your password. And I would basically explain to you why we are doing this. And then you've got this Docker username. It will stay as is IAM API key. So that's basically for IBM Cloud Container Registry. So you don't change that. Don't use any other username. The Docker server, in this case, because my image was stored in us.icr.io, I'm going to use us.icr.io. But if you want to if you are using another container registry, you can basically change that. So that's the Docker server for this command. And then you need a secret name. So let's call this my app project secret. This is just a name that you choose for your secret. And then you need to definitely make sure that you use the right namespace or project, as we called it, my app project. That was the name of our project. So for this one, the command is OC namespace, your project name, and then create secret. Again, quite obvious. And then you need to basically use your Docker registry. You basically say secret Docker registry. You need to say Docker registry as a keyword for that. So that's basically the type of secret you're creating. And then you need to say the name of the secret that you're going to create. So that basically you assign a name to that. And then your Docker server, your Docker username, in this case is defined by IBM, is IAM API key. And then the Docker password is your API key that you've just created, plus an email address, which is Docker email in the end. That's as simple as that. So you just basically add all this information, and then you can basically create your secret. I'm hoping that I've input everything correctly. And let's see. Yes, my secret is created. My app project secret, as you can see, it's got the secret, dash. That means it is a resource now. It is a secret, like a service, like a deployment, and I've got that created in my namespace. So remember this, it's in my app project. So this secret is already somewhere. And now what we are going to do is we're going to add this to our default service account within that project. I keep on saying that because it's sometimes confusing between default project and default service account, but we are going to add this image pull secret to our default service account within that my app project. And the way you do that, as I said to you before, we are going to use a patch command to look into the image pull secrets and then change that to add this new secret name by changing the JSON formatted description of that resource. So I'm going to use this OC patch. So just for you to know, is OC patch the name of the project, -n the project name, and then your service account, which is default service account for that project, service account /default, and then the type is a JSON type. And then basically you say, here's the description of the image pool secret within that service account, and I'm going to add it as a secret name. So that secret name in the end basically defines your the secret name that we've just created. So I'm going to go ahead here and say, then copy paste this, and instead of here I'm basically going to put my app project secret. So my app project secret is now there. One thing we could basically do is we could basically get the secrets. So I think it's a good idea to do that before we go ahead and make this change. I think it's good to take a look at. I'm going to delete this. I could have used the one below, actually would have been much better. But I'm going to delete it all. But here's the thing. So one thing we can do now, we can basically take a look at the secrets in the namespace just to make sure that the one that we just created is actually there. So I would say OC get secrets, and then N, and then my app project secrets. Let's get all the secrets. So it gives us all the secrets. As you can see, the bottom line says my app project secret, so that's already available, that's already there. And then you need to describe the service account specifically, just to make sure your service account within that project, whether it's got it or not, because that secret is already basically exists in your namespace, but it's not in your service account. And the way you do that is OC describe service account default. OC describe service account, then default, and then we don't need to use any dash, and my app repo, my app project. So it's going to basically show us all the secrets within the service account, default service account. As you can see, this is the image pool secret already available there. This is the one, default Docker CFG. So our secret that we looked at before, my app project secret, is not there. And now with the next command, now we can go ahead and use this command. It was quite useful. Let's use it here. So I can basically go ahead and use the image pool secret. So my app project secret is added, the secret is there. Don't change anything in this JSON description. And then the service account is default, and then you need to define the project name. And obviously the project name is my app project. That's all. I'm hoping I've put everything here. Just make sure you use the quotation marks and everything like perfectly, because it is a JSON formatted description, and it easily can go wrong and wait for more input. So it's now added. So the service account, default service account, is now patched. So if I go ahead and take a look at it again, as you saw previously, OC describe service account, it didn't show us anything in the image pool secret. And if I do it again, it is already there, as you can see. So my default service account has got my secret, image pool secret basically, and now it can actually go ahead and retrieve images, pull images from the container registry. This is very important. So if I hadn't done this bit, we would have got lots of errors and it would have basically failed. And to show you why it would have happened is I'm going to show you a quick example. Let's see, OC project, OC new project. Let's create a new project and then call this testing repo testing CR pool. So I just created a new project called CR pool, and I'm going to deploy, if you remember, OC. Let's get the name of the IBM Cloud Registry, CR image list. So I'm going to basically use one of those images just to show you that it's not going to work. there, and then I'm going to say OC create deployment, and then call it my test, my CR test. Let's call it my CR test. Even the deployment, we're going to call it the same, and then image is going to be this one, the very one that we're going to basically use now with the other one that's got the pull secret. My app v1. So I'm basically creating deployment in the new project that is called what was it called again? Totally forgotten what it's called. My app, my something. Anyway, so we basically created a new app. Why am I not finding it? So new project, testing CR pool. So I'm basically going to create a new deployment in testing CR pool project, just to see if it works, if we can pull an image from the container registry. Let's see. You saw that it worked perfectly in default one. So it is the deployment is created, but if I say OC get deployment, you remember the one for default project, it was very quick. The deployment was ready and we exposed it and we looked at it. OC get deployment, my CR test, but let's look at it again, is 0 out of 1. And again, look at it again, it's going to be 1 1 or 0 1. Basically the reason for that is if I get OC get events, what you can see here, it basically successfully assigned, created the container image, created basically already present, but anyway, created the my app, started container, back off, restarting failed container, created, and then scaled up to 1 replica set, and it keeps on going from 0 to 1 replica set, then going back to 0, going to 1. And the reason for that is if I go for another event, we're going to see the reason for that. And the reason for that is if it shows me, it hasn't actually figured out what the reason is that it can't make it happen. Let's get it again. OC get deployment. It is 0. OC get pods. You can say it's 0. But it basically we're gonna look at it. The pod is there, but if I do it again, it's gonna be 0 1. Right, 0 1. 0 1. As you can see, like it's 1 0 1 1 0 1. It keeps on trying and trying and trying, creating the container, but it basically fails. If I go for the events again, it should have that problem now clearly stated. But anyway, the problem is that it can't really pull the image from the container registry, and it says back off. Basically, there is this image pull back off that it keeps on trying and it can't, and it keeps on trying again. So this will go on and go on and go on for a very long time until it basically manages to do that. So as you have seen, we've just created image pull secrets and we've added it to our default service account within the new project we created in our OpenShift cluster. And that way you can always basically pull images from your private registries, and that's one way of using pull secrets in your OpenShift cluster. Now let's go ahead and so basically you can go ahead and create deployments and expose it exactly like we did in the beginning of the lab within our default project, but you can go ahead and do that from your project. What we're going to do now, we're going to basically take a look at scaling and replicas. If you remember from the previous lab, we had this concept of scaling and replica sets, and that basically allows us basically to create multiple instances of our application. And in this case, I'm going to create 3 more instances of my data parser, the app that we deployed in our default project. So I'm basically going to just scale it to 4 parts basically. So if I go back here and look for OC get deployment, so I've got 1 deployment, and if I look for my parts, it's going to be 1 part. So there's 1 part running, and that was the application we had. So now I'm going to basically clear my screen and set up a watch command to look for OC get parts every 3 seconds basically to query my OpenShift cluster for the number of parts. And then here I'm going to scale my application to 4 replicas. So OC scale and then replicas, I'm gonna use 4, and the deployment we're gonna use my app deploy. As you can see here, this is basically the command that we're going to use: OC scale replicas and then your resources. So here it is. So I basically just scale my application, deployment station, deploy. Oh, deploy. So I miss one O here. So as you can see now, there are 3 more pods added to my deployment. So now I've got 4 instances of my application running. So if I try to query, let's take a look at OC get services. So if I query my application, curl, and then external IP. So this IP and port number is different from the one that we used previously because I had to reset my cluster. So hello, to connect curl 139.92.0, it's the same. Okay, 219.168, and that must work fine. Yes, hello world. So it took a little bit of time. Let's clear and then run it again. Hello world. So it's now working basically, and then the type that we had, like the load balancer service that we've got, it basically decides where the request should go to each one of these pods, and it kind of create this really nice load balancing kind of model to send it only to the ones that have less basically load. So when the load hits our application and you need to scale, the load balancer is one of the ways that basically it can deal with that. And whatever happens to our pods, if they even get deleted, so for instance, if I say delete pod, and I'm just going to delete this pod, again exactly like we saw it in Kubernetes. So let's delete this pod. So this pod is now deleted. So as you can see, that's terminating, but OpenShift cluster basically tries to bring one back up immediately after that. So no matter how many times you try to delete a pod, that's going to come back on fairly quickly. It's towards the same zero downtime as we talked about OpenShift cluster and Kubernetes previously. So that's quite amazing when you look at it, when you've got applications, when you've got like so many pods and this sort of things needs to happen, and you've got your load balancer auto scaling basically, as we spoke last time. That can happen. If you don't know much about the scaling and replicas, please take a look at our previous lab when we talked about it in the Kubernetes context, and we went through all the details of replicas and also exposing for different type of services. In this case, we're using a load balancer. Obviously, I've included some other commands for you to create a node port. Exactly works the same, but obviously you don't get the IP address for it, and you can just call it through the node port. Just go ahead and take a look at that lab just to get some ideas about it. Now let's take a look at rolling out updates to our current deployment without causing a downtime. So that the way that OpenShift is going to handle that is by incrementally updating pods instances with new ones, and we are going to basically take a look at that as we've already got our pods for replicas running, and you can see how that would happen. So first of all, the way we are going to do that is I'm going to update the container with a new image. From basically we are going from the positive cases for COVID-19 to the death cases, and the updates are version, so you can basically just update your image and then go back and roll back to the previous one. So the way we're going to do it is basically we are going to swap these images and see the results. So I'm going to query a country, see the number of cases, and then we're going to basically query again, and then we're going to basically see the number of death. So if I go back here to my application that is already running, so when I look for Germany, you can see that we've got 206,000 for the 26th of July. So now let's go back to our slides. So the way we do that, we can use OC or kube control, doesn't matter. And what we're going to do is we're going to say set the image for the current deployment from for this container to this new image. So let's go back here. Let's take a look at our OC get pods. So these are the pods running, and then IBM Cloud CR image list. So when I basically look at my deployment, let's do that deployment again, but let's look at it wider scale. So this is the container, my app, and that's the image for it. I'm going to basically just set this image to a new image, and the way we do that is we say OC, or let's say in this case we use kube control set image deployment my app deploy, and then we basically we need to use the container name, which in this case is my app, and then put the new image, which is USICR my app. Let's do that. So deployment, container, and then the new image. So image updated. So if I look for my OC get services, just want to make sure that we are basically querying the right application 219.3.1.9.2. 219.3.1.9.2.0. So if I just query Germany again, and then I go down there, it is now 206. That's interesting. So probably we need to so if I try to get my image has been definitely updated. Let's get OC get deployment. Maybe our pods are still running. Let's look at OC get pods. Okay, so 3 of them are running, the other 2 are image pullback off. For some reasons they're not able to get it. My app repo, app depth. Okay, I think we put it the right way. Shouldn't have any problem. And the previous one was my app v1. Maybe we should have mentioned the tag name just in case. Let's take a look at it again, because the other ones are running successfully with no problem. Let's do it again. V1, in case that image, because we see that there's image pullback off, there might be problems for pulling that image from the container registry, and usually it could be just the way that we described our image. Let's take a look at it again. Yeah, OC get pods. Oh, it's running, so it must be okay. So now let's go back. So it's always good to test and see what's actually happening. So my service is down. Okay, let's go back here, look at the OC get services. It might be that the IP address has changed. Oh yes, so my app deploy, the IP address has changed. No, it is the same, 31920. So it's basically coming up, perhaps. The parts, they're all running and they're all ready 50 seconds ago. Let's look at OC get deployment. All of them are available and running. Okay, now it's back on. Great. As you can see, now I've got the number of cases on the 26th, 25th. As you can see, is 9,124. This is obviously way lower than 200,000, and that's basically the number of death, and you can basically check it out to make sure that it is the correct number. So we've basically just updated our image from the number of positive cases into the number of death. So you saw how easy it is basically just to make that update happen, and obviously we had a few errors and we managed to look into that. But the good thing is, if I want to actually go back based on this, as you can see, I've got my rollout. I can actually say kube control rollout undo, and then deployment, and then deployment. So that's just 1D. So I can say kube control rollout undo, then the deployment, my app deploy. So we've just went back to our previous image. Let's see, OC get pods. So as you can see, some of them are terminating, some of them are okay. So the other thing is, because our previous image was wrong, so we had to update it again, so probably it's not going to go back again. So let's put it back to the one that is the correct one and then redo it again. So now you remember that when we tried to update it, we updated it to the one without the tag, the right tag, so it was basically having problems to pull it back off, and that's exactly what happened again. So what I'm going to say is, I'm going to say go back to my app v1, so as we have it here and right here. Okay, so I'm going to say set image deployment, deploy my app. You see, let's send it back there. Let's clear the screen and also get parts. Okay, so one of them is terminating, the others are running. So what I'm going to do is, I'm going to basically try it again, since we wanted to see what it's like to do a rollout. Let's take a look at it and see what it's like. Set the image and let's send it back to that IBM Cloud CR image list. So that's my app death, which is right here, and then my app, that's all good. So we send it back again to number of death. Let's make sure that it's basically querying and we call the endpoint. So obviously it's going to take some time for it to come back on again. Once you get pods, again it's terminating and then running the new pods. Obviously it takes some time for pods to be updated. Again, let's wait for it a bit. So 36 seconds ago they all started, so it should be up and running. What did I do here? Okay, now it's back on. So the number of death is 9,000 again, and now I'm going to go back to the previous one. So I'm going to basically just say kube control rollout undo, and then deployment my app deploy. So it should basically go back to the number of positive cases rather than number of death. Let's see if it happens. Obviously it's going to take some time again. Let's wait. We're going to check it out, but then if you want to check the the good thing is kube control rollout status, so you can basically go ahead kube control rollout status and then deployment, then my app deploy. So successfully rolled out. So that's also a good thing for you to just check back if you want to see what it's like. Some other things, like for instance, if you want to go back to a particular revision, you can, but obviously you need to make sure that you've got the tag number correct. So you can basically --2 revision, then go back to 3, 1, 2, and this way is actually very useful because when you update your applications, you can always, you always have a way to go back to the previous rollout if any sort of error happens, and this is quite useful, and it's one of the powerful features of Kubernetes and OpenShift. Now let's check it out again, our application. Let's see what's happening to it. As you can see, now we are back to 200,000 cases, which means that is the positive cases, not the death cases anymore. So what we did here, we set our image, so we basically made some updates to our current deployment. Then we rolled out, we basically we went back to the previous version, and so that was rollout undo, and also you can check out the rollout the status that we did. So those are the sort of kind of things that you can actually do with your deployment from the command line with OpenShift. Again, we're going to take a look at it from the console, and you can see how easy it is basically to do the same sort of things from the web console. So that was our extensive kind of revision of useful commands for deploying an application, exposing an application, creating, scaling basically, and creating replica sets, and also updating the images, going back to the previous rollout, and going back to the previous version. So we basically went through everything. The next section, and obviously the most important one that took maybe much longer, was basically creating pool secrets for images, and that's basically something that we're going to take a look at it in the console section. You can see that the same sort of procedures that we followed for the CLI side, it's going to take only a few clicks for us to actually do. So let's go to the console. Now we are going to use the web console to implement all those tasks from the user interface that's provided by the OpenShift Container Platform. So let's go ahead and get started. So if I go back to my console, and then from the developer perspective, if you click on add, basically you get 6 different ways to create an application, component, or service. So I can easily just use my Git repo, or use a container image, or just choose something from the catalog, or the Docker file, or YAML, or database. So let's take a look at it from the catalog. So for instance, if I want to create a new Java application, first of all, I'm going to create a new project. I'm going to call this project my application, my app test. Let's create this project. So my project is now created. So if I search for JDK, that's basically the way I can instantiate a new Java application using OpenJDK. And that basically provides me with a template to create my application from scratch, and basically that pulls the image from this GitHub repo. Let's also take a look at other ones like Python, for instance. You can create an application, a Python application, basically from one of these builder image. And also, if I want to use, for instance, Node.js, here are the Node.js sample applications, or the ones that I can use from my Git. So let's take a look at JDK. So if I go for JDK 8 and I want to use a template, here's my namespace, and I would say latest version. That is the GitHub repo that is from the OpenShift side, and then I can just leave the rest of it as default. And if I go ahead and create my application, that is already done and ready, so I can just go back to my topology. So my build is still running, so when the build is finished, these arrows basically are going to turn into a check marker basically. And also, if I want to take a look at the some of the information about the config, build config, as you can see, I've got my build here, I've got my services, these are the resources, I've got my routes as well, so the route is going to be created automatically. and also if you go in here, once the deployment is ready, it's going to basically scale to 1, so that's by default, and I can just go ahead and scale it up or down as needed. Some other information, if I want to see what's actually happening, I can basically just press on here and see the logs. Now actually my application, my build is ready, it's completed, but here are the information about what's actually happening with that build, so you can just track all the logging from here. I'll just go back to my topology. Let's take a look at our OpenJDK app, the sample. So by just clicking on this icon, I can just open the route that has been created for me. As you can see, I've got hello world. So the JDK, the application based on OpenJDK is now up and running. So you see that it's quite simple. Didn't do anything like the ones we did from the command line. And that basically is one of the great functionalities of the console, basically, and how you can basically simplify all the processes by just using the web console. I'm going to go back here and basically just delete my deployment, because we are going to basically try and use our application from the Git repositories that we went through earlier in Kubernetes and OpenShift CLI, and we're going to basically try to deploy it from here and see how easy it is actually to do that. So I'm going to just delete my OpenJDK app. So it's now being deleted. As you can see, the pod is being terminated, and now we are back to topology, and we haven't got any application running at the moment. So in the same namespace, actually I'm going to try to create a new project. Let's call this my COVID test. Just going to use COVID test, create. So my new project is created. Now I'm going to basically pull it from Git. Let's see what we need from for this one. So for this one, I need the Git repo URL. So if I go into my URL, my GitHub, so here's the my GitHub URL for the positive cases, as we saw earlier. So I'm gonna go back here, copy paste it here. So it automatically got detected. That is Java 8. And then you can call your application, let's call it. So this is basically more like a group, so COVID-19 test, and then I'm going to call it COVID-19 positive. So this is basically, I'm saying this is for the positive cases. Then you get deployment or deployment config. They're essentially the same. Deployment basically uses replica sets, and it's more like a Kubernetes way of doing things. And then deployment config basically is more like an OpenShift container platform provided using a replication controller. And the only difference is the first one is basically based on, it's a set-based requirement, and the second one is quality-based. But essentially they're the same. It is recommended that you use deployment, but I'm going to go ahead and use deployment config. And then obviously you've got the extra option whether you want to create a route to your application or not. Since we are going to expose our application and access it externally, I'm going to keep it as is. And also you've got some advanced options like adding labels and other things. So I'm going to actually add it and say app backend, and also cases. No, I'll just leave it as is, and then it's good. Just let's keep it as app backend. So let's create it. So now I've got my application running. So my build is basically running. As you can see here, we can even check the logs here. So it's basically pulling the image from my Git. I can even basically look at some of the other things like the events. So as you can see, the build is running generated from the build controller. If I go back here, you can even look at the memory usage, CPU just once it's actually ready. The GitHub repository that is being pulled from. Some other information, because this is a Maven application, so basically it takes some time for it to download all the dependencies and the libraries basically, and it's for the first time basically I'm running it, so that's why the source to image takes much longer, but it's probably about a couple of minutes. It's not going to take much longer than that. So everything's going well. Let's go back to our topology. So as you can see, this ring is now lighter blue, so that means it is happening, the build is ready, but it hasn't been the route is not ready yet. So once the route is ready, that basically is going to turn into darker blue, as you can see it here. So now my application is ready, everything is good. So let's take a look at it on this side just to see what we've got. So here are our resources from the build config. You can see that we've got pods, builds, and services. We only got one part, and also the route is here. So this is the URL that this application is going to be accessible from. And also the overview, we've got one part running. I can easily just like scale it up and down, and because this is the first time we basically deployed this application, is version 1. We haven't made any changes. So what I'm going to do now is basically if I try to access it, as you can see, because if you remember from the previous section and also in the previous labs when we tried it on from the OpenShift CLI and Kubernetes, this application is available on port 8082. That's the way I've designed it. So if I go on this URL, it's not going to show me anything, obviously. So what I'm going to do, I'm going to basically make some changes to change the service port and the pod port here, as you can see. So what I'm going to do, again, if you remember from the CLI, I had to basically get the services, go in there, make all these changes. All I need to do is click on the services, and I can easily see the port mapping. I can see the IP address of the cluster IP. And then what I'm going to do is I'm going to say edit service. And then I get the YAML. In the YAML, I can see the ports here. So I don't need these ports. So I'll get rid of this. And then change this to 8082, 8082, and then I'm going to call this 8082 TCP. So I made these changes. Let's save it. And then go back to our topology. And then from here, I'm just going to basically trigger another deployment by starting the rollout. So now it's basically going to make the changes and make a new deployment. So here it is. So it is ready now. So let's take a look at it. So if I go in here, I didn't check it last time, but basically it's going to be like hello. Interesting. Should show us. It basically takes a little bit of time because we've got a Spring Boot and also the JDK as well. It takes a bit of time because containers usually, but obviously JDK and Spring Boot takes some time. So let's wait for it. Hello again. No, I haven't got it. Okay, let's go back and see what is actually wrong in there. So looking at the logs, so our Spring Boot, as you can see, is ready, it's running, and see, okay, so the application is still starting, so we need to wait a little bit longer because we just basically went for another rollout. And as you can see here, the memory usage basically went from 0 to 300 megabytes, and down here we can see that we got the node IP as well and the pod IP as well. So this is actually quite useful. We're going to use this later when we've got our UI, the front end, and we want to actually trigger basically access the positive data from the front end from our UI. So we're going to use the pod IP at some point. Great. So I'm guessing the application must be ready now. So let's go back there and take a look at our application again. Okay. So I've basically disabled the white pages, that's why you see this. So I'm going to say hello again. Oh, it's not running yet. Okay, so there must be something else. Let's take a look at it. Let's go back to our logs. Again, our application has definitely started. So there might be something else somewhere that we haven't actually changed. So if I go back to my pod and look at it here, let's go back to our admin perspective. I'm going to look into networking routes. Let's look at our route here. So everything seems to be normal. Oh, target port 8080. That's why it's not working. Okay, so we need to update this because I didn't basically change it from the route perspective. I only changed the other one. So let's change this one. Go to YAML, and this one, as you remember, was 8082. Save, and then let's go back to our application here and try it again from here. Aha, that's it. That's my HAL browser, so it's there. So as you can see, if I now try to say hello, yes, hello world response, I'm getting that. Now let's try to, without the browser, I just want to say hello, show you what it's like. And if I even try to access the country data, I can say get data, country data, and then Germany. I had seen that before, so that's why it's there. So that's all the data for Germany, for all the positive cases. Let's go down and see what we've got here. For the 23rd of July, we've got over 200,000 cases in Germany, as you can see. So that's basically our analytics working fine. So this is our application. The positive case is working fine. Now let's go ahead and see some information about it. So in the administrator again, if I go into my workload, I can see the pods, I can see the deployment. Obviously we didn't use any deployment, we used deployment configs, and that's what you can see here. And also the secrets, this is quite important. I'm just going to look at the service account. So let's get rid of this, and image. Yeah, so these are the basically the builder secrets. We're going to basically take a look at it later, but for now just know that we can actually access the secrets from here. Let's go back to developer perspective, and now we are going to try and scale our application. So let's go for 2 or 3 pods. So you can now see that it is actually scaling. So if I go back to my OC, to my terminal, so OC get pods, so as you can see, like one of them is ready, the other 2 are not, because those are the new ones we've just basically scaled. So if I do it again, probably they're going to be ready now. No, still going on. So the status is completed, but they're not running. It's 0 and a 1. Still going on. Let's wait and see. And also, if I want to take a look at my let's wait for that first, and we'll see it. We can basically just take a look at some of the logs, and then for this particular pod, if I want to see what's going on with this. Interesting. Maybe I just need to access it from here. So get logs, F, and then make sure I mention pod. Interesting. So maybe my pod has changed, so no, the pod is still there, but I don't, for some reasons I don't get the information about it. Oh, interesting. I just realized what I'm doing. So as you have seen, we have just scaled our application to 3 instances and it's now up and running. It happened very quickly, instantly, and now we're going to basically take a look at it from the CLI and see, some of the logs from the CLI and see what's happening. Let's go here, OC project, my COVID test. You're already on that project. So I'm gonna basically, let's get our pods. We'll see get pods. So we've got 6 pods. Obviously, 3 of them are for the previous one that we tried, with the first version when we had our route, to different port. Let's now try to get some information about it. So OC, OC logs -f, and let's see what's happening to this. So here's the log for that particular pod. So as you can see, the application is running. It's been running for some time, and let's take a look at the other one. I want to see what's actually happening to this one. So that was our build. The other one is deploy. The other one is deploy. I want to see what's going on with this. So instead of that, let's say So that's basically, there is a pod basically for my build, and that's all the information for that particular pod that was basically downloading all the information, all the dependencies and libraries for my Maven. As you can see, that was all the data, and it basically pushed it, it pulled it first and then pushed it into the registry, and we just basically saw all the logging information about that, and there was a pod specifically created for that. So that was actually quite interesting to see, and that's one of the reasons that the 3 other pods are not basically running, because they did their job and now they're finished and done. Cool. Let's go back to our topology. I want to bring that back down to 1. Okay, I didn't make it 0 today. Okay, good. And I'm gonna just take a look at it again. So as you can see, the other 2 pods are completely gone, and now we only have 1, so that they were completely terminated. So we are now back to 1 pod, 1 instance. For the logging information, the other way to look at it is from the advanced tab and then going into events. So you can basically see it here, and also you can filter it as well based on error and information, and also different types if you want it to be like, alert manager coming from build, from deployment. You can basically look at it from that perspective as well. So versus for deployment, we've got nothing, but if I go for, let's say, deployment config, for sure we've got some stuff happening here, because we basically used deployment config to create our application. As you can see that it happened about a few hours ago, and now we are basically 9 minutes, and so that's basically what's happening with that particular resource, so deployment config. again, let's go back to our topology. And also you can look at it from the administrator perspective as well. So if you go back into administrator and then go into events, you can basically look at all that information from the administrative perspective as well, and basically gives you a little bit more. So let's go back to our developer perspective. So from here I'm going to basically go ahead and deploy my user interface, my front end as well. So from Git, and if I remember my UI correctly, okay, so that's it. That's for my UI. It's going to get detected again. I'm basically going to put it in the same group, so I use COVID-19 test, and then for this one I just call it UI, and then deployment config, and obviously we want to have a route for it as well. And I'm gonna add a label, so app front end, and then I'm gonna basically add one more thing, user interface model user interface. So I've got basically two labels, just the front end one, the app front end, is actually quite important. It's just a customized something that I really want to kind of identify my application, this particular application, later if I want to connect my applications together, or I want to use the service discovery later, and that is quite useful. So let's go ahead and create it. Again, the same goes like the previous one. Takes a little bit of time, and if I just click on this, I can see all the logs. What's happening is obviously pulling from GitHub, as you can see, it's cloning, and then since it is a Maven one, it's going to go ahead and get all the information from there as well. There's some other information, some other basically controls that you need to be aware of. So from the let's go to the topology whilst this build is running. If you go into advanced and then project access, from here basically I can decide whether I want to grant access to other users to access my project, and the type of access is basically either you can basically grant admin access, view, or edit, and it's basically quite straightforward, as you can see here. But then the name should be a user that that you have in mind, and it doesn't necessarily need to be to exist already, but you can just add it here. And also this is just one way of granting access. The other way, if you go back here and for instance for my application, from here if I to role binding, let's go into my namespace first. So from here, from my namespace or project, if I go to role bindings, let's just take a look at our namespace role bindings. So we've got admin. So those are basically service accounts. So there are service accounts that are basically associated to your project when your project is created, and they get injected and associated with once every pod is basically created. So you can create service accounts, and there's a service account called default that is in charge of creating all those pods, and you can basically bind some access control through this service account association. So we're going to get to this later in our future labs, but for now, just for you to know that you can use role binding to give access to different namespaces and also different resources in your application to if you want to kind of allow them to communicate and also access different resources. And there's also a very nice way of using this resource control for accessing your resources externally, without sharing your credentials. So for instance, we are now logged into our console with my username and password. If you don't want to do that, you can create tokens, and that's basically done through these role bindings and creating secrets. So we're going to basically get to that later, and you're going to learn about it. But for now, you know that you can actually add some role bindings from here. Just to give you some ideas, I can call my role binding like, something like developer, and then the role name is going to be admin. Let's say if I want to give admin access, or if I want to say just view, I can just go for view. So, and then basically is that going to be a service account, or is it going to be a user, or is it going to be a group? If it's going to be a service account, I'm going to use this namespace, so my COVID test, and then subject name, I can just call it, as I said, default is the one that is in charge of creating all those pods and stuff, so we can just use default. And if I press on create, that service binding is going to be added as a viewer, basically, by view with the role of view. So I'm not going to do that, so let's cancel it and go back to our topology. So now our application is ready. I think it's the same story like what we had with the previous deployment config. So let's take a look at it. Obviously, if I go into the route, it's not going to bring it up. Let's just close this. As you can see, the port numbers, the pod port and the service ports are not the ones that we have designed our application with. So this one, the UI, the front end, if you remember, that's on port 8081. So I'm going to go ahead again, do the same thing. So let's just edit it. And I can actually, let's edit it from here. Edit service. Let's get rid of this and just leave 8081, 8081, and we're going to call it 81. And then we need to go back to route again like last time and then change that as well. So let's save this back here. I'm going to go back to my administrator, go into business work. Oh, that's working. Yeah. Oh, I'm blanking. And now for my UI, go in here and just go to YAML. Obviously, we need to change that to 8081 target port. Save. Let's go back to our developer perspective. There's a better way to change that, by the way. I'm just basically giving you the shortcut, so that makes it easier. So if I just go for the rollout again, it's going to trigger another rollout. So here it is, my container. Here you go. One is getting terminated, the other one is running, and it must be ready now. Yes. Okay. Hopefully, it's going to basically show us the UI. There you go. Here you go. Yeah, we've got it. Cool. So now I'm going to connect to my positive cases to my application that basically parses, to my data parsers that parses positive cases. If I go in here and get the positive cases, I can basically use this route, copy, and then go back here and then copy paste it. So here it is. So I'm basically accessing my data parser. So just let's test it. All data for the country, and then I'm going to use Argentina, load, and here's all the data for Argentina for the positive cases. But basically now it's using my route to get into to retrieve all that data, to pull all that data from our parser. But since that pod is already there running the data inside the cluster, I can use the pod IP address to access it, the IP address and port number. So what I'm going to do, I'm going to just basically use the pod here. This is going to be a pod IP. So this is a pod IP, and if I go back here and just reset and connect, so instead of all that, I'm going to just say I use this IP address and then port 8082. It should work. Yes. So basically now it is the pod running my UI and the pod running my parser are now connected. When you add labels, you can basically make them discover each other without even hard coding. But the way I've designed my application is that I want to be able to switch between different pods, the different application, different parsers for positive and death cases. That's why I'm doing this in here. Otherwise, your application is able to find that regardless of the IP address, because every time a new pod is created, every time you kill a pod, a new pod is created, the IP address is not necessarily the same. So using the labels and the service, basically you can always make sure, and the route obviously, you can always make sure that your applications are able to discover each other. So now we've got it basically. Again, if you want to test it, let's take a look at, for instance, Brazil. And you can see all the data is retrieved, and obviously now it's 228,000 cases in Brazil. Positive cases. Oh, no, actually, it's 2,200,000 cases in Brazil. I was actually thinking about it because it must be way higher than that. So that's basically the positive cases for COVID-19, as you can see. So it's getting the data from Johns Hopkins University repo and then getting pushed into here and then parsed, and then our UI is connecting to get access to it, and we can basically run these sample functions to retrieve the bit of data that you're interested in. So that was all it takes basically to deploy our applications. It's quite simple, straightforward. Just from a web console, you can easily deploy your applications. There are other ways to do that. As you can see, you can basically just go ahead for your YAML file. You can even use your Docker file as well. So there are different kind of ways to do that. In the previous section, we showed you how you can actually pull it from IBM Container Registry. The ICR that we use to pull our image. First we pushed it and then we pulled it. So the same can apply here. So you can basically use that container image instead of using the source code. And if you use the container image, you just basically copy paste the image registry, and that's all basically takes to again go ahead and create a deploy or deployment config. I hope you've enjoyed this section. I'm sure you've seen how productive you can get basically by using the OpenShift Web Console. So let's go back here. I'm just going to basically fast forward to the section because we've already gone through everything. Just for the sake of this slide deck, basically all these screenshots are included with some instructions on my GitHub, so you can go ahead and take a look at it. But we've already seen everything, and we've also demoed the application. So in this section, we looked at why OpenShift matters. We compared Kubernetes versus OpenShift, and we saw how much OpenShift can actually expedite your journey from application development to production and deployment and production. And also we looked at using CLI tool exactly the way that we use Kubernetes, but obviously with all those extra bits and pieces that OpenShift basically adds security to every part of your deployment. And also we use the console to make everything much easier and more straightforward for developers. Obviously, as a developer, you want to do everything very quickly and much faster rather than spending time to basically learn all those CLI tools. So we've basically gone through everything, and you've got a fairly good idea of all the basics of OpenShift Web Console and OpenShift CLI. And the source to image obviously is one of the most important feature of OpenShift, as we saw. So in this next section, we are going to look at code-ready workspaces, and code-ready workspaces is one of those really interesting features of OpenShift. As you can see, as you will see, We are going to use an in-browser IDE to write our code and deploy it. We don't even need to go to our GitHub anymore, so you can do everything from there. And at the same time, you can share it with your other team members, and everybody can contribute without causing any interference. And at the same time, you've got full access, full control over access and how you want to grant access, different types of access to different team members. And that's basically going to be the topic and the focus of our next workshop. I hope you've enjoyed this workshop. It was a very long workshop, obviously, and I'm looking forward to see you in our next workshop for code ready workspaces. Stay tuned and see you in the next lab.